As we pointed out in the R3 introduction, we can multiply or divide the numerator and denominator of a fraction by the same number to get an equivalent fraction. And what that is it just looks different, but it has the same value. Remember the 1/2 and 3/6. We can multiply to raise a fraction to higher terms. This will be really important in the next section, R4. Or we can divide the top and the bottom, the numerator and the denominator, by the same number to reduce or to simplify fractions to the lowest terms. Okay, so we'll take a look at that first one, raising fractions to higher terms first. So we see here that I have the same fraction, 2/3, listed twice. So we know that we can do, since fractions are just division, multiplication and division are compatible with fractions, meaning you can multiply or divide the numerator and the denominator by the same number. So when we're going to higher terms, we're obviously going to multiply. So if we take 2/3 and multiply the top by 10 and the bottom by 10, so we multiply the top and the bottom by the same number, we would get 20/30ths, or 20 divided by 30. These two fractions look different, but they mean they have the same value. Likewise, we can take 2/3, and this time let's say, I feel like multiplying top and bottom by 7. As long as you're multiplying the top and bottom by the same number, we would get 14/21, which is also an equivalent fraction. We will see in R4 that we'll decide what we want that denominator to be, and we'll determine what we have to multiply that original denominator by to get there. Okay, but we'll see more of that in R4. Let's take a look at reducing fractions. So, as pointed out, the long way to say this is reducing fractions to lowest terms, or just simplifying fractions. There are basically two ways to do this, but in both cases you're going to be dividing the numerator and the denominator by the same number. So in the first case, you just start with the fractions as they are and divide top and bottom by the same number, and it may be a continuous process until you can't do it any further. Or the second way we'll look at is using prime factorization. So let's take a look at that first way. So we will start with the fraction 12/18. So what you want to ask yourself is, well, what could I divide both top and bottom by to reduce that? So what goes into both 12 and 18? Well, I'm thinking, 6 goes into both of those, so I'm going to divide by 6, divide by 6. So in the numerator, we will have 12 divided by 6, 18 divided by 6, and when you divide that out, you get, there's our little friend 2/3 again. Let me show you another way to take a look at this. You don't have to start with the greatest common factor, in other words, the biggest number that goes into both of those. If you look at 12 and 18, you may go, I know that 2 goes into both of those, so I'm going to take 12 divided by 2 and 18 divided by 2, and we would get 6/9. Then you say, when we get 6/9, can we take both of those numbers and divide by the same thing? I go, 3 goes into both of those, so 6 divided by 3, 9 divided by 3, and we would get 2/3. So in this second way to do it, in both we ended up with 2/3, which is what we ended up with as in the first one, but it just took us a little bit longer. Okay, so there's no harm done in taking a little bit longer to get there. Okay, let's look at the second way, and I think from now on I'm going to use that second way. It's a little bit more work at the beginning, but you're much less likely to make mistakes. So let's just stick with that 12/18. So what we're going to be doing in this second way, we're going to be using prime factorization. So we're going to take our factor tree, split 12 apart, and find out what it's made of. Remember this. We can stop, we can stop, we can stop. So 12 actually, when we tear it apart, is 2 times 2 times 3. And 18, if we did the same process to 18, we would get 2 times 3 times 3. Then it's very easy to see what we can cancel or divide out. So I see a 2 in the numerator and the denominator. Cancel both of those. When we cancel, we're actually dividing. So 2 divided by 2 is 1, 2 divided by 2 is 1. Anything else you see we can cancel? There's a 3 in the numerator and a 3 in the denominator. And again, what we're actually doing when we cancel is we're dividing. So we're going to end up with, there's nothing more to cancel. And what we're going to end up with is what's ever left over. All that's left over in the top is 2 times 1 times 1, which is just 2. And downstairs we'll have 1 times 1 times 3. There we go, to get 2/3. A little note. When you're working with fractions, especially when we get to R4, I'm just going to give you a preview. And R4 deals with adding and subtracting fractions. Your last step is always, can I simplify? Or you can say, can I reduce? So you're always going to have to ask that in the last step for addition and subtraction problems. Okay, I think we can then go to multiplication, which is, if you can simplify fractions, you can multiply fractions, because it's just a bigger simplification problem. It's the same process. So I will see you in R3c.